Welcome to lecture 37, templates and generics. So we had seen some examples, right, with respect to C++, what do you mean by template, and we have written some programs if you recall in the last lecture, all right. So on the continuation, so here what we can do, we can have a template class with the multiple data members. In fact, we had seen template function and a template class as well, and here I will be continuing with the template class with multiple data members. So let us assume, right, in this example this template class is storing pair of values, right, of different types, pair of values of different types. So here you see template, so this is syntax and I am going to use type name T1 and another one is type name T2. So let us have class pair, all right. So let us have class pair, correct. So T1 first, T2 second. Suppose I am using one is integer, another one is double. So T1 integer, it is equivalent to int first, double second, okay. So now you have a constructor, parameterized constructor, you have A, one parameter is A, another argument is B, one argument is A, another argument is B, and then you are copying A into first and B into second, correct. So this is a constructor, parameterized constructor. And then you have two functions, member functions, get first, return type is T1, get second, return type is T2, all right. So it is returning first and second, not a very difficult program. So here you have, so let us say class pair, this is the syntax, you have to mention one is int, another one is double. In the last class we have done, let us say assume pair, only one template, right. So only one type. So in that case what we have done, pair int and then close the angle bracket. So here we are using two, right, the pair of values, right. So in that case you put int comma double, that means T1 is int and T2 is double in this case, right. So you are creating an object my pair and then passing 10 comma 20.5. So therefore it will call the parameterized constructor, right. A is assigned to first, that means first is equal to 10, right, that is the meaning, and the second will be equal to 20.5, right, second will be equal to 20.5. So line number 15 you have first, so this will be printed, my pair is invoking get first, right, my pair is invoking get first. So get first, it is returning first. So what is first? 10. So this will produce 10, this will give output 10, and second will be printed, my pair is invoking get second, right, get second returns second, second will be 20.5, 20.5 will be printed, right. So this is the first case. And the second case you have pair, you have string and integer, now it is a string. So now T1 is string, T2 is integer. So this is what the advantage, right. And then you are creating an object person under pair, name is Alice, age is 30, right. So something like that, two arguments, right, two values you are passing, right. So one is string, another one is integer, integer value, all right. And then you are printing, next line name you are printing. So person is invoking, this is object is invoking get first. So get first, when it is invoking, here you have return first. So what is your first? Alice. Similarly, right, you are printing age, person is invoking get second. What is get second? 30, correct. So this is because you are passing this, A is assigned to first, B is assigned to second, right. So Alice is assigned to first and 30 is assigned to second, right. So now this is the advantage. So in one case I am using it as integer and double, another case I am using string and integer. You may have one more, let us say double comma double possible, right, or double comma integer, float comma integer. So it is possible. So that is the advantage of the template class and template functions, right. So let us run the code. So template class with multiple data members, all right. Yes, my pair 10 comma 20.5, person, Alice and 30. If we run the code, yes, we are getting the output. First is 10 and second is 20.5, name Alice, age 30, okay. So this is what the output we can get, right. So this is the advantage of using the template class. So let us see one more example. So this is a specialized template class in C++, right. So one is the usual one, line number 4 to 10, all right, template type name T, class storage, right, is a template class, you have one member data value whose data type is T, and then you have member function storage, right, val, passing one value. So, that val will be stored in value, right. So, this one, which is a constructor. Line number 8 is nothing but a constructor, parameterized constructor. And line number 9, you have get value function, member function, whose return type is T and it is returning the value, right. So, this is the usual template class that we had seen. So, now you are seeing the specialized template class with the same name, right. So, but what you are doing when you look at line number 12, you are using this particular syntax, template angle bracket only, without anything, right, template angle bracket, and then you are using class storage, right. So, class storage is a specialization, right, or you call it as a specialized template class storage, and then here you have string, previously T. So, the T will be for any data type, and here storage we have string, specialized one, the specialization for string, and then you have set of statement, you have value which is a data type whose class is string, right, whose data type is string, value is the variable whose data type is string, and here you have constructor storage, you are passing one value whose data type is string, and that will be copied, val will be copied into value, exactly what we have done previously. Only one member function which is a print member function which is not available over there. So, string storage, so this will be printed. Okay. So, this is what the difference between the usual template and the specialized template. So, in this particular case the specialized template is for the string. So, now you go, alright. So, here assume that you have created an object in storage, right. Here you are passing 100, and then if you look at the class storage and then your type, right. So, the template type is integer, type name is integer T, right, capital T is becoming integer, you are passing 100, right. When I am passing 100, now value is equal to 100, right, and then you are having a cout statement, integer storage. So, this will be printed, and in storage, right, you have created an object which is invoking get value. So, when it is invoking get value, value will be printed. What is the value? 100, 100 will be printed, right. Now, we'll go to line number 5. So, I have string storage, right, str storage, another object under storage std string, that is a specialized template, right. So, that means this will call this particular function, right. So, let us see, you are passing hello world, right. So, that means the constructor will be called and val will be copied into value, it is a string, you are passing string, what you are passing? You are passing hello world, right. Now, value is nothing but hello world, correct. So, when I am calling this print using the str storage, that means str storage is invoking the print function, print member function. So, this will be printed, string storage, what is the value? Hello world, string storage will be printed hello world, one is 100 will be my output, integer storage 100, here string storage hello world, right. So, let us run the code in C++, yeah. So, we have a specialized one, line number 11, and when I run the code, compile and run the code, yes, I am getting the output, integer storage 100 and string storage hello world, okay. I hope it is clear for everyone. Also, we can have template class with the default parameters, right. So, we use T, U, T1, T2, something like that, right. So, in that case, what we can do, so assume that I put, right. So, assume that I put one type T, type name 1 is integer, another type name U is double, right, default. So, that means T here class data pair, T first, U second. So, initially without loss of generality, your T is integer and U is double. So, that means it is equivalent to int first and double second. So, now you have data pair which is a constructor, 2 argument constructor, you have 2 parameters A and B. So, A is copied into first and B is copied into second. So, whatever you are passing, it will be copied respectively first and second. So, now you have a function, let us say this is a member function get first, alright. So, your return type is T, that means the integer. So, it is returning first. Second one get second, by default it is U, that means a double, it is returning second, okay. So, now let us go to the main program. So, you have data pair. If I do not put anything in the angle bracket, it is considered as a default. What is default? Integer and double. You are using two type names, one is integer, another one is double. So, you have integer 10 and double 20.5, right. You have a integer 10 and double 20.5, that means you have an object default pair, right. You are passing 10 and 25, correct. So, you are passing 10 and 20.5, right. So, what will happen? So, here you will first will be 10, right. Here you have first and second as the variable, right. So, now it is by default integer and double, correct. So, 10 you are passing, that is A. So, first will be now 10 and second will be now 20.5, clear. And then let us assume, I mean it is printing C out, default pair is an object calling get first. So, get first, when it is calling get first, it is returning first. What is first? 10. So, I will get the output 10. And second case, default pair is calling get second you will get, it will return second is 20.5. So, this is the case of default, right. So, now you may ask the question, so can I use this T and U for any other data types, right? Yes, the answer is yes. We are going to see line number 17. So, here what we are doing, data pair, correct, same class name, here you put character and float. If you do not put only the angle bracket without anything, it will be a default. So, here in this case, even though the default is T and U, integer and double, here in this case what I am doing, I am completely changing it, right. So, data pair I put character and float. So, when you do this, T is becoming character and U is becoming float, right. So, it is like in the procedural oriented programming, you put int A equal to 10 initially, right. You can declare like this, and then at one point of time what you are doing, you can do A plus plus, right. So, similarly by default, right. So, here it is integer and double. So, later I am changing it, or A equal to A plus 2, same variable, now it is a different value, right. So, the same template class, now your T and U are different, T is character, U is float, and then you are creating one object custom pair, your character is A and your next one float is 3.14 F, F stands for float, correct. So, now see out, first it will print, custom pair is invoking get first, right, custom pair is invoking get first. So, get first is returning first. So, what is first now? A, right, this is being copied, A is being copied into first, 3.14 F is copied into second, correct. So, custom pair when it is invoking get first, A will be printed, correct, and the second will be printed, first also will be printed, second will be printed, and custom pair is now invoking get second is returning second. What is second? Second is nothing but 3.14, right. So, this is the output we will get when you run the code, alright. So, this is the output we are getting. So, first is 10, second is 20.5, and in the second case first is A, second is 3.14, alright. So, this is what the output you are getting, first is 10, second is 20.5. So, you run the code, it is not very difficult, A and second is 3.14, right. So, this is what the explanation of the previous code. So, I have completely done that. So, when you are seeing for your notes, so what exactly we have done. So, if you put only the angle bracket, it will be considered as default. So, in this case default was integer and double, and you may ask the question, so can we use this T and U for other data type? The answer is yes, and we have seen, right, and it is changing to character and float. So, accordingly your first and second is changing, and then we can able to get the output like this, right. So, this is called the template class with default parameters, right. So many advantages we have, so many benefits we have, code reusability, right. So, we had seen when you are using function or class, so no need to use again and again, no need to write the code again and again, maximum of 2 numbers, integers, maximum of 2 doubles, right, maximum of 2 characters. So, no need to write again and again. So, that is what it is reducing the redundancy, alright. Also it is promoting do not repeat yourself, no need to repeat. Suppose I am asking you to write a program to find out maximum of 2 integers and maximum of 2 doubles, right. So, before this concept what you have to do? You have to write separately, whereas now you do not repeat this, that is called the do not repeat yourself principle, right. So, which is eliminating the duplicate code. Again, you have to use the same logic, right, when you are writing maximum of 2 numbers, whatever be the numbers, alright. So, that is saving, that is called the code reusability and type safety at compile time. So, any errors, so that will be caught during compilation time itself, alright. So, it will be avoiding the runtime issues. And when I am talking about type safety, so it is a strong type checking, right. It is enforcing the strong type checking, especially which is useful in large code bases with varied data structures, right. We talked about type safety when you are using, let us say, integers, maximum of 2 numbers and the 2 numbers are integers, and then you are using for doubles. So, the type safety will be there, data type safety will be there. Performance optimization, of course, when you are using, let us say, the maximum of 2 integers, doubles and let us say characters, 2 characters are given, which is the maximum, right, based on the ASCII value. So, we no need to repeat the code again. So, that will give you the optimized code, alright, and the compilation is also only for that particular, suppose it is a function I am talking, class also, right. So, the code will be optimized one, particularly when you want to efficient code, alright, or you are participating in some of the contests, right, it is advisable to use template. So, the performance will be optimized and you have the additional features like the flexibility and scalability, right. So, these are all the major benefits of templates. Also, when we talk about STL, standard template library, particularly when you are doing data structures, alright. So, when you use, let us say, stack, queues, linked list, right. So, you have standard template library, right. So, it is having the collection like a vector, map, set, list, linked list, etc., right. So, in fact, these data structures you can reuse and in fact, you can store any type, right. So, which is improving the modularity. Also, mathematical and algorithmic libraries, assume that if you are using the maximum, minimum, many mathematical functions, square root, right, ceil function, floor function. So, this can operate on any numeric type, right. So, the templates you can operate on any numerical types, like you have libraries like a linear algebra or graph algorithms or numerical methods, right. So, the template is having high edge over your usual traditional approach. Also, we have the concept of smart pointers, right, smart pointers and memory management, alright. So, you can cleverly do this, right. So, we have smart pointers like unique underscore PTR, you try, right. So, unique underscore PTR or shared underscore PTR. So, this can handle the memory for any object type, alright. So, these are all the essential features. In fact, when I am talking about the benefits, these are all 4 important benefits and these are all nothing but the use cases, right. Generic data structures you can use like a vector, map, set, list and linked list, etc., right. So many you can go through that, and mathematical and algorithmic libraries with the help of templates, right. Also, the memory management we can use the smart pointers. Also, you have right some more use cases like a compile time polymorphism, alright. We talked about compile time polymorphism, right, function overloading, operator overloading, alright. So, these are all nothing but the compile time polymorphism. So, like this here, if you get any error, right, so that can be pointed out during your compilation time itself, alright. So, the template, when you are using a template, that is allowing the polymorphism, right. So, we no need to worry about the runtime overhead like virtual function, alright, and also the customizable algorithms. So, algorithms which are working with any data type, right. So, which can be implemented using templates, right. So, this is providing flexibility and type safety. So, if I talk about any examples, so any generic scoring functions or searching algorithms and data processing utilities, these are all the customizable algorithms. So, the use cases of templates, the go like this, you can have the generic data structures, mathematical and algorithmic libraries, smart pointers, right, compile time polymorphism and customizable algorithm. So, the next concept what we are going to see generics, right. I will have the basic introduction. So, like a template class, template functions that we had seen in C++, in Java we have generics, alright. So, the concept is generics, exactly like a template class and template function that we had seen. So, here, so this is enforcing type safety, same like in C++. So, that is at the compile time, right. So, when it is allowing, right, while allowing classes and methods, right. So, here in this case classes and methods we call to operate on any specified data type. So, whatever we define templates in C++, here we call it as generics in Java, alright. So, it is introduced in Java 5. So, the generics, which is enabling a type or method to be a placeholder for types. So, that means when you are using, assume that classes and interfaces, right. So, we talked about classes and interfaces. So, there I mean we can use generics. So, generics which are able to, right, to create the classes, interfaces and methods, right. So, here I mean in the C++ we talked about classes and member functions, right, classes and in fact functions, template functions, and here in this case you can have a generic class, generic interface and generic methods. When I am talking about C++ templates, alright, so there you can have the multiple type specific classes, we had seen multiple type specific classes. So, whereas in the case of a Java we have some restrictions, right. So, we cannot have the multiple type specific classes, right. So, that is the difference, that is the major difference, right. So, there we can use, in fact we have seen the example, right. So, multiple type specific classes, whereas here that is not available, that is not compiled like C++. So, here also you can have the code reusability, right, and data safety, etc., right. So, when I am using a single class or method, alright, so that can work with the multiple types. So, exactly like what we had taken the example, maximum of, right, 2 numbers, integers, alright. So, I can have one single method. So, the numbers may be integer, may be double, may be let us say character or even maybe string, you are comparing 2 string and we can say, right, which one is greater, alright. So, this you can have only one method, and that method when you are talking about generic, one method, and that method can be useful for multiple types, exactly same. What we have studied in C++, we call those are templates. So, here we are going to call it as generics, right. So, only few things are not available, for so far we had seen this is not available, whereas the multiple type specific classes we had seen in C++, right. So, here we do not have obviously. So, since everything is happening during compile time, it is preventing the runtime, right. So, if there is any exception, so that will be caught during the compile time itself, alright. So, what we can do in the next lecture, we will talk about some examples of generics under Java. Thank you.